Well, this topic is about finding the minimum of certain functions. We are going to do, let's say, problem 8, 9, and 10. Okay, we practice this problem. How to find the absolute maximum of the absolute minimum. Okay, let's go to find the absolute maximum of minimum in the interval x smaller than 1/2 and bigger than 1/2 and smaller than 3. So in this interval, let's go to find the absolute maximum of the absolute minimum. How we will detect the absolute maximum? We will take the function g of x, which is x plus 1 divided by x, and we will do the derivative of the function. What is the derivative of the function of g prime of x? What is the derivative? Well, it's g prime of x, which is, what is the derivative of x? Is 1. What is the derivative of 1 divided by x? Is minus 1 divided by x squared. So we are looking for the places, for the point x where the slope is 0. These are the relative maximum or minimum, here or here. So we say when g prime of x is 0, when g prime of x is 0, when 1 minus 1 divided by x squared is 0. And when this happens, when 1 is equal 1 divided by x squared. And when this happens, when x squared equal 1. And when this happens when x equal plus square root of 1. In the interval that we are considering, that is the interval 1/2, 3, in this interval, this is the 0, this is 1/2, this is 1, 2, and 3. In this interval, the only point in consideration is the 1. So at the 1, there is a critical point. Is a maximum or is a minimum? To know this, we plot f prime of x. So we make this line. We put 1/2. We put 1, 2, and 3. And we know here the slope f prime of x. The slope is 0 here, but we don't know if it's a maximum or a minimum. So we take a point to the left, let's say 1/2, and we see what's the value of f prime of 1/2. What's the value of g prime, sorry. Is g prime the name of the function, g prime of x. G prime of x, so let's go to correct. G prime of x, g prime of x, and g prime of 1/2. So we see to the left of 1/2, let's say here, and we see to the right of 1/2, let's say here. What happens if f g prime of 1/2? G prime of 1/2 will be 1 minus 1 divided by 1/2 square, which is 1/4. 1 divided by 1/4 is 4. 1 minus 4 is 3. It's minus 3. Minus 3. So the slope here is negative slope. If I see a 2, g prime of 2, what will be? 1 minus 1/4. 2 squared is 4. 1 divided minus 1/4 is 3/4 and is positive. So here the slope is positive. Here on this interval the slope is positive. So the curve will do like this. Will do something like this, negative slope, and here positive slope. That say that at x equal 1 you have a minimum, a relative minimum, that is also an absolute minimum. So it's the smallest value. What is the smallest value of g of 1? G of 1, at the point g of 1, the function is 1 plus 1 divided by 1. It's 1 plus 1 divided by 1. So it's 2. And this is the minimum value of the function. So the function must be do like this on this interval. At x equal 1 is a minimum, so the function on the interval 1/2, 3, will do something like this. We'll do a minimum, and later on we'll go a maximum. So at the point x equal 1, the value is 2. So the x equal 1 is a minimum, and the minimum value that it takes the function is 2. For other value on the interval will be bigger values. Okay. If you graph it, to finalize, if you graph this function in GeoGebra, you will find this. You will find that this is the function x plus 1 divided by x. It has a vertical asymptote at x equals 0, because at x equals 0 the function is not defined. And the maximum is here, the minimum is here. Here is the minimum, and there is a maximum, but this one is not on the interval that they say. They say for 1/2 that is here to 3. So this is the relative minimum and the relative absolute and the absolute minimum. This one, x equal 1. Okay. Okay, let's go now to practice the same idea to find the absolute maximum or minimum of this function on this interval. The interval is -2, -1/2. Okay. Okay, we have to find the critical points. The critical points, let's go to find first the derivative. If we find the derivative f prime of t, this is the derivative of two functions. The numerator is t squared, the denominator is t minus 1. So we apply the quotient rule. The derivative of the numerator multiplied by the denominator minus the numerator, t squared, multiplied by the derivative of the denominator. The derivative of the denominator is the derivative of t minus 1. The derivative of t is 1. The derivative of 1 is 0. So it's multiplied by 1. Divided by the denominator square, t minus 1 squared. Okay, the interval is t bigger than -2 and smaller than -1/2. It's an interval that is at the left of the 0. It's between -1/2 and -2. It's here. The interval is in this region. So you see at t equal 1, the slope doesn't exist, but t equal 1 is not on this interval. So I'm not worried. So the question is, when f prime of t is equal 0? When 2t, when the numerator is 0, when 2t multiplied by t minus 1 minus t squared is equal 0. Or when 2t squared minus t squared minus 2t equals 0. Or 2t squared minus 2t minus t squared, so this is t squared minus 2t equals 0. Or t that multiply t minus 2 equals 0. So, when this is 0, when t equals 2. Or when t equals 0. But 0 and 2 is not on the interval. Then there are not points with a slope 0 on the interval -1, -2. So we need to do like this. If t equals -1/2, what is f of t? F of t is t squared divided by t minus 1. T squared divided by t minus 1. So it will be -1/2 squared, which is plus 1/4, divided by t squared, t minus 1. Minus 1 is -3/2. So the value of the function evaluated at t equal -1/2 is -2/3 multiplied by 1/4, or in other words, -2 divided by 12, which is -1 divided by 6. So now I'm going to the end points of the interval. T equal -2. The interval is the interval -2 -1/2. Okay, so if I go, I see what is the value of the function at -2. It would be -2 squared, which is 4, -2 minus 1 minus 3 is -4/3. So what is the absolute minimum? The absolute minimum is the minimum value, is -4/3. So at x equal -2, the value is -4/3. At x equal -1/2, the value is -1/6. -1/6, a small value. What is the biggest, the maximum? The maximum value is here. Is here at x equal -1/2. What is the minimum on this interval -1, -2? Is this one, because the curve have no maximum, no minimum, and is doing something like this on this interval. It has an asymptote at x equal 1, so probably the curve is doing like this, and it goes to the asymptote. Conclusion, the absolute minimum value happen to be at x equal -2. This is the, and the absolute maximum value, it happened to be at x equal -1/2 in the interval -2 -1/2. Okay, let's go to another problem. Now let's go to this problem. Problem 35 say an art gallery can offer 50 prints by a famous artist. So the function that relates the quantity with the price, Q of P, is the function 500 minus 2P. It's a rectilinear line with the slope -2. And if you represent the function Q of P equal 500 minus 2P, this is the function. For a price P of 250, the quantity that it will be sold, it will be 500 minus 2 multiplied by 250, will be 0. So you are here. So the first question say, what is the limitation? What are the limitations of the possible range of price? Well, price 0 is one limitation for the possible range of price. And the other thing is that they offer 50 prints. So when Q is 225, the value, when P is 225, 2 by 225 will be 450. 500 minus 450 will be 50. So the minimum amount that they can offer is the the amount that they can offer is 50 prints. So they can offer 50 prints. They may offer 30 prints, 20 prints, 5 prints, and the price goes like this. As they offer a smaller amount, a bigger price, as they offer at a bigger price, the amount is smaller. Okay, so what they say, what is the limitation? So the limitation should be for the price should be between 225 and 250. Now it say find the elasticity of demand. Determine the value of P for which the demand is elastic or inelastic and of unit elastic. Okay, the elasticity E depends on the price P. And the elasticity is measured by the following equation. It measures the amount of quantity that it will be sold, the percentage of the quantity that it will be sold when you change the price in a percentage, in a certain percentage. So the elasticity is the percentage of change in the quantity divided by the percentage of change in the price. Now the percentage of change in the quantity, remember, this is Q, this is DDQ, a small change in the quantity. So the percentage of change in the quantity is DDQ divided by Q multiplied by 100. For the price happen to be the same equation. The percentage of change in the quantity, in the price is, this is the price, P, and you make a chain, delta P. So the change is, the percentage of change is DDP divided by P multiplied by 100. So if I make the division of these two, it will have DDQ divided by DDP, the 100 cancel, and we will have P divided by Q. So this is the equation for the elasticity. Now let's go to see what is the elasticity. They ask, what is the elasticity at any price? Any price between 225 and 250. Okay, what is the elasticity? Well, the elasticity E of P is P divided by Q by the derivative of Q respect to the P. But Q of P is 500 minus 2P. So the derivative of Q respect to the P is minus 2. So E of P is P divided by Q multiplied by minus 2. Normally, we consider the absolute value of the elasticity. So the absolute value of the elasticity, E of P, is P divided by Q by 2. 2P divided by Q. 2P divided by Q. What is the elasticity when the price P is, for example, 225? When the price P is 225, the Q is 50. So it will be, E of P will be, P is 225, Q is 50 multiplied by 2. So the elasticity will be 450 divided by 50, or 6. Indeed, is minus 6, but we consider the absolute value. So the absolute value of the elasticity is 6. So if it's 6, it means bigger than 1 is elastic, less than 1 is inelastic. What is the elasticity E when the price P is 250? Is P divided by Q, P divided by Q, P is 250, Q is 0. Oh, let's go to be very, so if Q is 0, we cannot divide by 0. But let's go to a Q very small. Let's say Q equal 10 minus 1. 10 minus 1, very small quantity. So you are here. You are here. You are very, very near to the 250, to the P250, but not on the 250. So let's put it 249. So 249, and what is the value when it's 249? Q of P is 500 minus 2P. If P is 249, Q is 500 minus 2 times 249. So Q will be 500, 249, it will be 498. So Q will be 2. So what will be P divided by Q? When you are next, very close to the point 250, let's say 249, P is 249, Q is 2, and the elasticity is always 2 or minus 2. But in absolute value, there will be 2. So the elasticity will be 2 divided by, it will be 249. 2 divided by 2. So the elasticity is elastic all the time, in all the interval. Because at the beginning of the interval, when the P is 250, 225, and the Q is 50, is 6. So the elasticity is always elastic. Remember that if E of P is bigger than 1, the E is elastic. The elasticity of the demand is elastic. And when it's smaller than 1, is inelastic. Now let's go to find the elasticity for any price, not in the interval 225, 250, for any P, for any price. So the elasticity is E of P is Q divided by P, P divided by Q by the derivative of Q respect to the P. And I want to know the derivative of Q respect to the P, because Q of P is 500 minus 2P, the derivative of Q is minus 2 always. So what happened? When the P is positive always, Q is always positive. When P of Q, when P divided by Q multiplied by minus 2, when in absolute value, so this will be 2P divided by Q, when this is bigger than 1, when 2P is bigger than Q. When P is bigger than Q divided by 2, how I can know the value of P and Q when P is bigger than Q of, well, P bigger than Q divided by 2 means P bigger than Q, but Q is 500 minus 2P divided by 2. So it means that 2P is bigger than 500 minus 2P. is meaning that 4p is bigger than 500. So for p bigger than 500 divided by 2 by 4, for p bigger than 500 divided by 4, 125, the elasticity is bigger than 1. So it's elastic for p bigger than 125. So the demand, the elasticity of the demand is E bigger than 1 if P is bigger than 125. And E is 1 if P is how much? Is P is 125. Because if P is 125, 4 times 125 will be equal 500. And E is smaller than 1, meaning that here is elastic, and here will be inelastic. When it will be inelastic? Inelastic when if P is smaller than 125. And this is the result. And now let's solve the last question. The last question say, if you were the owner of the gallery, what price would you charge for each print? Explain the reasoning behind your decision. So if you were the owner, you want to have the maximum revenue. We suppose that the cost of the print is 0. So the revenue R of P will be the price multiplied by the quantity. The price is P and the quantity is 500 minus 2P, and I want to know what is the maximum, at what price P the curve achieve his maximum. How I will find this? I will look, well, let's go to write this like 500p minus 2p squared. So how I will look the maximum? I will find the derivative of the revenue respect to the price. And the derivative of the revenue respect to the price will be 500 minus 4p. And I want to set up this equal 0 to have the slope 0. To be a maximum. I hope it's a maximum and not a minimum. Of course, it's a maximum. So the derivative of R respect to the P equals 0 means that 500 is equal 4P. It means that if you sell at the price 500 divided by 4 or $125 per print, you will do the best possible business to sell an infinite amount of to sell any amount of prints, because at this price you don't have 50. You see, the price 125 is here. Okay, if you want to have to sell and earn the best possible situation will be when you sell at the price 225, because you can only sell 50. If you sell big at a smaller price, you will at a bigger price you will get a smaller money, because you sell less print, less quantity of print. So here is the maximum revenue at 125. Unit degrees. Okay. This problem says a city recreation department plans to build a rectangular playground. So the rectangular playground can be imagined to be like this, rectangular. So this will be x, this will be x, this will be y, this will be y, this will be y, this will be y. So the area here is 2x multiplied by 2y. And the length here, the length of the fence is 2x plus 2y. And what we want is, this area is fixed, is 3,600 square meters. And what we want is to minimize the length. So this function is what we want to minimize the length. So the area is 4x multiplied by y equal 3,600. So y is 3,600 divided by 4x. So the length L of x, it will be 2x plus 2y. 2y means 2 times 3,600 divided by 4x. Or in other words, 2x plus 3,600, 2 divided by 4 is a 2, 1,800. 1,800 divided by x. And this is the function that we have to minimize. So let's go to find to which x the function is the minimum. So the derivative of L respect to the x will be 2 plus or minus 1,800 by the derivative of 1 divided by x, which is minus 1 divided by x squared. And I want this to be 0. I want to find the slope that is 0, when the slope is 0. And when the slope is 0, it's a maximum or a minimum. So 2 equal 1,800 divided by x squared, or in other words, x squared equal 1,800 divided by 2, or in other words, x squared is 900, and in other words, x equal, I have to use the positive, because a negative length have no sense, is a square root of 900. And the square root of 900 is 30. 30 by 30 is 900. So the dimension of the rectangular fence is x equal 30 here, 30, 30, 30. And what is y? Well, if x is 30, y is here. Y is 3,600 when x is 30 is 4 divided by 30. So the 0 will cancel and I have 3,060 divided by 12. So the y will be 3,016 divided 60 divided by 12 is 30 by 12. 30. So it's a rectangular. This is 30. The y is 30 and 30, 30 and 30. So at the end it's a square, right? It's 60 here, 60 here, 60 here, and 60 here. So to maximize the area, to maximize the length, so you need a length L of 60 by 4. The length is 60 times 4, which is 240 meters of fence. With 240 meters of fence, you can do an area of 3,600 meters square. And this is the max, if you want to minimize, this is the minimum 240, the minimum size that you have to construct a fence to make possible that you have an area of 3,600 square meter. Okay, let's go to another problem. It decrease. Now let's go to do problem 11. It's a store has been selling a popular computer game at the price of $40 per unit. So the price P is $40 per unit. And at this price, the quantity is 50 units. So the point here is the P, the price. Here is the quantity. When the price is 40, the quantity is 50. So let's go 10, 20, 30, 40, and 50. When the quantity is 50, the price is $40. 40. So let's go to put here 10, 20, 30, and 40. So this is a point in the problem. So this is the problem. This is the point Q, P. Q, P, or the point 50, 40. Okay, let's go to rate. 50 is the quantity. This has been buying. Okay, the owner of the store wished to raise the price. So he is at this point. He wants to raise the price by how much? In a way that if he raises $1, if he goes to 41, the quantity will be decreased in 3 units. So 3 units decrease will be 1, 2, and 3 units. So now the points will be $1 you increase for a, let me read it again. The owner of the store wished to raise the price of the game to estimate that for each $1 increase, so you increase $1, the quantity will decrease in 3 units. 3 units. So now you are at the point. Which point is this one? This is the point. You decrease, you start here at 50, you decrease 3 units, so you are at 47. So, and the price is 41. So this point is the point 47,51 in the price. So it's Q, P, the quantity and the price. And of course, there is a rectilinear line that joins the 2 points. And they say if each unit costs $25, what price should the game be sold to maximize the profit? So let's go to find P of Q. P of Q is this rectilinear line. So how we will find this rectilinear line? How? Well, this rectilinear line is found by applying our equation for a rectilinear line. So P equal P initial, P0, plus the slope multiplied by Q minus Q0. Okay. P equal P0. So the point, initial point is this one. What is P0? 51. 51 plus the slope. What is the slope? The slope is the change in P divided by the change in Q. The change in P is $1, and the change in Q is 3 units. And they decrease the 3 units, so the slope is minus 1/3. So it's minus 1/3 multiplied by Q minus the Q0 at the initial point. And the Q0 at the initial point is 51. Minus 51. So this is the price P as a function of Q. And the cost of every unit, the cost of 1 unit is $25. And the cost of Q unit is 25 multiplied by Q. So the expression for the C of Q, the cost, will be 25Q. And the profit P of Q, the profit for the amount of quantity that you sell, is Q, the quantity, multiplied by the price P of Q, minus the cost C of Q. This quantity Q multiplied by P of Q is the total amount of money, the quantity, let's say 10 units, by the price per unit is the total amount of units, the 10 units by, let's say $10, $100 is coming here, minus the cost of 10 units would be 250 units. So you're better sell at higher price not to lose any money. So let's go to find the function P of Q. The function P of Q will be the profit. The profit for any quantity Q will be Q by the price P of Q. The price P of Q is this one, is 51 plus 51 divided by 3 minus 1/3 of Q. Or, in other words, 51 multiplied by 3, which is 153, plus 51 divided by 3 minus 1/3 of Q. Or, in other words, 153 is 204 divided by 3 minus 1/3 of Q. This is P of Q. P of Q. So how much is 204 divided by 3? Is 80, 70, 60, 65. 65 should be. Doesn't matter. Q by the price P of Q, 204 divided by 3 minus 1/3 of Q, minus C of Q, 25Q. So P of Q will be 204 divided by 3Q minus 1/3 Q squared minus 25Q. So the profit P of Q will be, I can subtract this for this, it would be minus 1/3 Q squared plus 204 divided by 3 minus 25 multiplied by Q. So the function P of Q will be minus 1/3 Q squared plus 204 divided by 3 minus 75 divided by 3 multiplied by Q. So the profit P of Q will be minus 1/3 Q squared plus 204 minus 75 divided by 3 multiplied by Q. 200 minus 75 is 225, so 229. 229 divided by 3 multiplied by Q. Okay, and now I want to maximize the profit, so I need to find the derivative of P respect to the Q put it equal to 0, and find what is Q. What is Q? The derivative of P respect to the Q is minus 2/3 by Q plus 229 divided by 3. And I want this to be 0 to find the maximum or the minimum value to maximize. I want to maximize the profit. I don't want to minimize the profit. So I expect that this value of Q is the value that will maximize the profit. So minus 2/3 multiplied by Q is 229 divided by 3 minus. So I change it to minus sign plus, I erase the 3, so 2Q equal 229. So the Q will be 229 divided by 2, so the quantity will be 110 units, 115 units. I didn't make any mistake. Let me see. Minus 2/3, I made the derivative Q, and 200, no, I didn't make any mistake. So this is the quantity. So what is the price P of this quantity? The price P of Q is here. The price P of Q is this expression, is this rectilinear line, 204 divided by 3 minus 1/3 of Q. 204 divided by 3 minus 1/3 of Q. So if Q is 115, P of the price when the quantity is 115 is 204 divided by 3 minus 115 divided by 3, or 204, 200 minus 100 is 100, 104. 104 is 190, 90, around 90 divided by 3. This is the price P. This is the price you have to sell to maximize the profit. When you maximize the profit, the quantity that you are selling is 115. Okay, let's go to do this problem. Say it is estimated that the cost of constructing an office building is this expression. So it say if you are going to construct only one floor, the cost will be C of 1. And C of 1 will be 2 multiplied by 1 squared plus 500 by 1 plus 600. So the cost will be 502 plus 600 will be $1,102. So $1,000. So the question is, how many floors should the building have to minimize the average cost per floor? The average cost per floor, the average is the total cost divided by the number n of floors. And I need to minimize this average cost per floor. Okay, so the average per floor is C of n. C of n is 2n squared plus 500n plus 600 divided by the number n of floor. So the average A of n is 2n plus 500 divided by 600 divided by n. And I want to minimize, to find n, to find the number of floors that minimize this expression. So the derivative of A respect to the n, it will be 2 plus 0 minus 600 divided by n squared. And I want this expression to be 0 to find the maximum or the minimum. In this case, I want to find the minimum average. what is the average of floor that I can? So it will be 2 equals 600 divided by n squared. So n squared will be 600 divided by 2. So n squared will be 300. So n will be a square root of 300. What is a square root of 300? 15 by 15 is 255. It will be around 17 floor. So this is the result. If you construct 70 floors, your average cost will be minimized. And how we know that it will be minimized? Well, you have to do the second derivative to see that it's a minimum. This is a minimum. Okay, let's go to do this problem. It's about Kamal is a print shop. He has to print a page. The total area of the page should be 648 square centimeters. Okay. By margin of 2 centimeters on each side and 4 centimeters on the top and bottom. Oh, so the picture is like this, and I did the wrong picture. So this is, let's go to put it in black. This is the page where you can write, but you need to place certain margins. So this page will have a y height and an x width. But they say that you need to respect a margin of 2 centimeters on each side. So 2 centimeters here, 2 centimeters here, and 2 centimeters here. So let me erase the y here. The y is this height, this is y, and this is x. And I need to respect 2 centimeters here to each side, and 4 centimeters here on the top and the bottom. 4 centimeters here. So how it will be my picture, my page, the page to print? It will be 2 centimeters here, 2 centimeters here, 4 centimeters here, 4 centimeters here. So this is. So the area to print will be this one. And the total area will be 648. So the question is, what is the dimension that minimizes the total area? So the area will be this is x, so it's x plus 4. The length will be x plus 4, and the height will be y plus 4, y plus 8, y plus 8. So the area will be x plus 4 multiplied by x, y plus 8. So I need to find what will be x and y. What is the dimension of this red area here? Should be like this, x and y, or should be more x and less y? And the total area here have to be 648. I understand that the total area, let me read it, receive an order to produce a rectangular poster of print surrounded, no. This is not the total area. The total area is x by y. So the total area is 648. So this area is an x plus y is 648. So I need to minimize this function, the area. So the area will be x plus y plus ax plus 4y plus 32. Okay. X by y, so the total area will be x by y, but it's 648 plus ax. Let me see. X by y, ax, 4y, 4y, 4y plus 32, plus 4y plus 32. But now I know how is y. Y is 648 divided by x. Now the area will be 648 plus ax plus 4 multiplied by 648 divided by x plus 32. What I want is to minimize this area, to find the derivative of a respect to the x, to make it equal 0, and to find which is the x that maximize the area that will be here, this area. So finding the x and finding y, I find the shape of the page. How rectangular has to be, if it's like this or it's more like this. Okay, let's go to do it. So I have this area. What is the derivative of a respect to the x? The derivative of a respect to the x, is 0 plus 8 plus 640 minus 648 multiplied by 4 divided by x squared. The derivative of 32 is 0. And I want to make this equal 0. So 8 is 648 multiplied by 4 divided by x squared. So x squared is 648 multiplied by 4 divided by 8. 4 divided by 8 is a 2. So x squared is 648 divided by 2, or 324. So x squared, x is a square root of 324. How much is the square root of 324? 15 is 225, 20 is 400, so it's something between maybe 17 centimeters, because the area was in centimeters square. So what is the y? The y is here. The y is 648 divided by x. So 648 divided by what? By x. By 17. 648 divided by 17. And this is approximately how much? 20, 10 times is 200, 30 times 30 times, more or less 30 by 20, 600, maybe less, maybe 28. You make the figure. So the size of the page, x and y, the size of the page here is the 4 centimeters, but the size of the page should be 17 here, 17 here, or a square root of 324, and 648 divided by 17, which is, I think, is 28. Okay, and that's the problem. It's a problem of optimization. Sorry, 624, 324 square root. This is 25. This is almost 25. So 620, so the y, the dimension would be divide by 25, divide by 25 here, 648 divided by 25. And what will be this? It will be, let's go to erase here, 648 divided by 25 is equal, 648 divided by 25 is equal to 25.92. And the square root of 324 square root is 18. 18, sorry, my calculator. Sorry, this is 18, and the y is, let's go to erase, the y is 648 divided by 18 equal 648 divided by 18 is equal to 36. So this is the dimension of the page that he has to build, to print, to maximize the area, to have a 64/8 square centimeters. Okay, let's go to do problem 45. It says a carpenter has been asked to build an open box. So in the top there is no material with a square base, So this is x by y. The box is like this. This is x and this is y, but x equal y. So this is x by x. Now it says this is the box, x by y and z. And this is the height of the box, c. C, okay, c and c. What is the volume that is here? The volume is the area of the vase by the height. The area of the vase is x squared, and the height is c. And what the problem is asking is, you build a box like this one. The top, no material. But this material will cost $3 per square. $3 per square. So what is the area that is here? The area that is here is theta multiplied by x. And the cost of this side of the box will be $3 per square, $3 per square foot or square meter, multiplied by the area, by the square, theta by x. So the cost will be 3 times theta by x. But there are two equal sides, so the cost of these two sides, of the left side and the right side, it will be 6 times theta by x. Now we go to the cost of this part. It costs $3 per square foot. So the cost of the other two sides will be x by c multiplied by $3 per square foot. But there are two sides, so it will be 2 times x by 3, x by c. So the cost of these two sides, this one here, and the one that is here, will be this. So the total cost will be equal 6 times zeta by x plus 6 times x by c plus the cost of the base. And the cost of the base is $4 per square foot. So it's $4 per square foot multiplied by the square foot that you will build. The square foot of the base is x squared. So this is the total C of x. C of zeta and x. It depends on x and zeta. And what it says, what are the dimensions of the box? What is the x, the y, the x and the z? What is the x and the z? What are the dimensions if you want the volume to be 48? Oh no. What are the dimensions of the box of the greatest volume that can be constructed for $48? So you want the cost to be $48. So this should be $48. And the volume, we say that is x squared by c. But I know who is c. Let's go to find who is c. The cos c is 48. 48 is 6 is c that multiply, I'm working with this equation, z that multiplies 6x plus 6x plus 4x squared. Okay, z, x by c. So this costs 3 times c by x. Let me see, 3 times 6 by x. Multiplied by 2 is 6 times 6 by x. C by x, yeah, it's 6 times, it's 12 times. X by c is 12 times x by c. So the cost, let's go to erase here, is 12 times x by multiplied by c plus 4 times x squared. If I divide by 4, it will be 12 equal x multiplied by c plus x squared. 48 divided by 12, by 4 is 12. 12 divided by 12 here is 1. And 4 divided by 1, okay, this equation. So this equation will allow me to find c. So 12 minus x squared divided by x, this is c. So I want to maximize the volume, to spend money and to have a box with the maximum volume. What I will do? So the volume is x squared multiplied by c, or x squared multiplied by 12 minus x squared divided by x. Or the volume is x multiplied by 12 minus x squared. So I want to maximize the volume, means to find for which x the slope is 0. So the slope of this one, I can write it like this, x 12 minus x squared, 12x minus x cubed, so the derivative of the volume with respect to the x will be 12 minus 3x squared. And I want this to be 0. So I want 12 to be 3x squared. I want 12 divided by 3 to be x squared. I want 4x squared to be 4, or x equal to, oh, I found. For x equal to, and the other side of the base is also 2 by 2, and the c, oh, the c is here. What is the c? The c is 12 minus, we said 2, 12 minus 2 squared minus 4 divided by 2. So the c is 12 minus 4 is 8, divided by 2 is 4. So what is the size? The size is x equal 2, c equal 4. So with $48, I can build a box that is 2 by 2 by 4. And I spent $48 and I have the maximum volume in this box. This is the box that have the maximum volume. Any other box different with $48 will have less volume. This is the maximum volume. And this volume is 2 by 2 by 4. 2 by 2 by 4 is 16. So you cannot construct any with $48 and with the price of, I think it was $3 per square foot here, and on the back, and here was $4, I think, I don't remember, and $4, you cannot construct a better box with a bigger volume with $48 than this one, 2 by 2 by 4. How to do this problem, elasticity of the demand. Suppose that the demand Q of P is 60 minus 0.1 P. When the price P vary between 0 and $600, I suppose. Express the elasticity as a function of P. What is the equation that we found? I think it was P divided by Q by the derivative of Q respect to the P. This is the equation for the elasticity, and the elasticity say how much change in percentage of the quantity you can do to find the change in the price. So this is the change in percentage of the quantity divided by the change in the percentage of the price. So if this is 5, if you make a percentual change in the quantity of 5%, you will have a 25, you will have 5 times. If you make a change of, let's go to erase here, let me erase here. If you make a change in the price, a percentual change of, let's say, 10%, it means that the percentual change of the quantity will vary in 5 times multiplied by the percentual change in the price. So the elasticity, this 5, say, be careful. If you change the price in 10%, you may change the quantity that is being sold in 5 multiplied by 10 in 50%. So you have to be careful when you take decisions, because the elasticity tells you if this is a good decision. No one wants to sell a smaller quantity like 50% if they increase the price in 10%. So you need to have elasticity, let's say 1. If you have elasticity 1, this is a good condition, because if you change the price by 10%, the percentual change in the quantity will be also 10%. So it's fair. But if you are in a point in the curve with this is 5, you can make bad decision. You have to know. Okay, let's go to do part A. Part A is straightforward. E of P is P divided by Q by the derivative of Q respect to the P. The derivative of Q respect to the P is minus 0.1. But remember, the minus sign in economics, they talk always about a positive, the absolute value of E of P. So to give you a better expression as a function of p, E of p will be p divided by q, 60 minus 0.1 p multiplied by minus 0.1. And this is the solution for the part A. For the part B, it's a calculate the elasticity of the demand when the price P is 200 and interpret the result. If P is 200, how much is the elasticity? E of 200 will be 200 divided by 60 minus 0.1 for 200 is 20 multiplied by 0.1 minus 0.1. So this will be 200 by 0.1 is 20 divided by 60 minus 20 is 40. So the elasticity will be 2 divided by 4 will be 1/2. What it means, this 1/2? It means that the percentual change in the quantity divided by the percentual change in the price is 1/2. What it means this? It means that if you make a 10% change in the price, you will expect that the quantity delta Q will be 1/2 of the percentual change. The percentual quantity that you will lose, that you will less, that you will not lose, sell, will be by 10%. So the percentual change in the quantity that is sold, that you will not sell, is 5%. So you increase 10% in the price, but the quantity that you are going to sell is decreasing only in 5%. It's decreasing because there are minus sign here, and it's minus always. It's minus here. And the part C say at what price the elasticity of the demand equal 1. Well, we take this expression and we put it equal 1. Let's go to do it. Part C. We know that E of P is P divided by 60 minus 0.1, P divided by 60 minus 0.1 P multiplied by 0.1 with the minus sign. So I want this to be 1 or minus 1, I don't know, because the elasticity is always negative. So indeed the problem is say when this is minus 1. The elasticity is always negative. So at which P this is 1? Well, it's a question of working with this. 0.1 P equal 0.1 equal a minus 1 that minus 0.1 P equal minus 1 that multiplies 60 minus 0.1 P. So minus is plus. With this minus to the other side will be minus 0.2 P. Minus 0.2 P is minus 60. So the price P that the elasticity is 1 is 60 divided by 0.2. But 0.2 is 2 divided by 10. So it's 600 divided by 2. So it's 300. So the price of 300, the elasticity is 1. And that solved the problem. Okay, let's go to do this problem. That is a problem of optimization. It says you want to construct a fence and you have to use 300 meters. So the length of the fence will be 300 meters. And the length is composed of all this length, x and x, y, x, and y. So it will be 2x, it will be 4x, plus 3y. This is the length. Okay. It say like this, and the length should be 300. How should as shown in the comment, how should he do this to make the combined area of the plots as larger as possible? The combined area is A1 plus A2, where A1 is this one and A2 is this one. So the combined area is x plus y plus x plus y. So it's 2x plus y. This is the area. So he wants to do the area at maximum as possible. So the area will be 2x by y. And the length, 300, will be 4x plus 3y. That means that 300 minus 4x divided by 3 is the y. That means that the area A is 2x multiplied by y, by 300 minus 4x divided by 3. That means that the area will be 300x, and x minus 8x squared. Okay. Minus, no, sorry. No, let me erase here. It's too late, I'm tired. I'm not fast. Okay, it will be 2/3 x multiplied by 300 minus 4 multiplied by 2x multiplied by x divided by 3. So it will be 2/3 300 divided by 3 is 100 minus 4 by 2, 8x squared divided by 3. So it will be equal 200x, 300 between 3, 300 between 3 is 100, 2 by 100 is 200, 200x, minus 8/3 x squared. Let me check the 8/3. X squared is checked, x squared is here, 8/8. Yes, it's correct. So this is the area, so I want to maximize the area. So what I should do? To maximize the area, I do the derivative of A respect to the x. So the area A will vary with respect to x. So if you have more x, the area will be like this. So I want to find this particular x when the slope is 0. I want to find the maximum of the area. So the derivative of A respect to the x is 200 minus 16 divided by 3x. And this should be equal 0. So this means that 16 divided by 3x is equal 200. It means that 60x equals 600. 3 by 200, 600. So the x is 600 divided by 60. So this is the x that maximizes the area. And how much it is? Well, you take the calculator and you know how much is the x. And once that you know the x, you know the y. Why you know the y? Because the length is 300. So if you know the x, you can know the y. Okay, let's go to do it. The 600 divided by 16, let me go take the calculator. Let me take the calculator. 600, let me do here C. Let me do here, okay. What happened here? Just a moment. Okay, 600 is 37.5. And because I know that the length is 300 and the length is here, The length is 4x plus 3y. 4x plus 3y. Now I know the y. So 300, I know the x, 4 by 37.5 plus 3y. So 300 minus 4 by 37.5 divided by 3 is the y. So I have the size of the fence. And the problem is done.